To become a fossil is to defy cosmic odds. Across the unfathomable depths of geologic time, a fleeting moment of preservation is an astronomical stroke of luck, a chance so infinitesimal that for any single organism, it borders on the impossible. This is why the fossil record, for all its wonders, is a book with countless missing pages. The Earth has been a stage for trillions upon trillions of organisms. They have come and gone in waves of creation and extinction. At this very moment, quintillions of individual animals share this planet with us. Given this sheer volume of life, it is no surprise that their remains are found constantly, fueling entire industries built upon the bones of the past. Yet, for all this abundance, most discoveries are familiar. They are echoes of a story we have already heard. Even the unearthing of a new species is often just a variation on a known theme. Another hadrosaur, another trilobite, a slight deviation in an established lineage. But sometimes, on the rarest of occasions, the Earth gives up a secret so profound it challenges our very understanding of life's blueprint. We stumble upon an enigma. There is no better example than Tully monstrum. Affectionately known as the Tully monster, the name is no accident. This creature was not merely strange, it was an anatomical paradox, a biological riddle that continues to confound science. Its modern story begins in the year 1966. An amateur collector was exploring the rich Carboniferous deposits of the Mazon Creek Formation in Illinois when he uncovered not one, but several impressions of a truly bizarre animal. It was clearly a single type of creature, but one that fit nowhere in the known tree of life. Baffled, he took his finds to the experts at the Field Museum of Natural History. To his astonishment, they were just as mystified. Imagine a soft, cigar-shaped body. From its tail, a triangular fin. From its torso, a pair of eyes extended outward, ending not in a mouth, but in a grasping, tooth-lined claw. It was a creature torn from the pages of science fiction, an alien form made real, its unsettling appearance tempered only by its modest size. Most specimens measure less than 35 centimeters. The discovery sparked a global debate. Hypotheses flew. Was it a mollusk, an arthropod, a conodont, perhaps a bizarre worm, a tunicate, or even an early vertebrate? The only certainty was its habitat. Though Illinois is now the prairie state, hundreds of millions of years ago it was submerged beneath a shallow tropical sea. The Tully monster was a free-swimming marine predator, occasionally washed into the silty lagoons where its form could be preserved. More than half a century has passed. Our knowledge has barely advanced. We have confirmed only that it belongs to the Bilateria, the group of animals with bilateral symmetry. This is a fact of almost no consequence, as it includes 99% of all animal life, from insects to humans. The central argument, whether it possessed a backbone, still rages. Time and again, scientists have declared the mystery solved, only for their conclusions to be challenged and dismantled by new analysis. The Tully monster resists classification. It remains a ghost in the evolutionary machine, a testament to the fact that life's ancient history is far stranger than we can possibly imagine. It is a quiet, profound reminder that some chapters of Earth's story are written in a language we have yet to decipher. The deep past is another world, governed by rules we can only glimpse. In its murky waters, where sunlight struggled to penetrate the silt, life experimented with forms both terrifying and sublime. Some of these ancient hunters are known to us, their ghosts pieced together from stone. But others remain absolute enigmas, their very existence a challenge to our understanding of biology. Among these profound puzzles, few are as baffling as a creature unearthed in the state of Montana in the year 1970. Pulled from the 330-million-year-old strata of the Bear Gulch limestone, this fossilized organism was so unusual, so divorced from any known branch on the tree of life, that it earned the nickname the alien goldfish. Its formal name is Typhlosis. This find, even more ancient than the famed Tully monster, presented a riddle so complete that for years the scientific community seemed to hold a collective, bewildered silence. No one, it seemed, was eager to tackle this impossible jigsaw. The fossil revealed a tiny, elongated body culminating in a single distinct tail, a clear indication that Typhlosus was an active swimmer, navigating the primeval seas under its own power. But beyond that, the picture dissolved into absolute darkness. There were no external limbs, no discernible midsection or torso, no anus. It was a creature of unsettling simplicity, a streamlined phantom, and yet, within its form lay a feature of unparalleled strangeness, an organ never seen before or since in the entire chronicle of life. Scientists named it the ferrolith. Analysis showed it contained an exceptionally high concentration of iron. What was its purpose? To this day, no one knows. When faced with a creature so ancient and so strange, the first instinct is to assign it to an equally strange and ancient group. The prime candidates were the conodonts. A widespread coalescence gained momentum with the discovery of a new specimen, one that appeared to possess teeth remarkably similar to those of a conodont. It was a moment of potential breakthrough, a glimmer of order in the chaos. But under closer scrutiny, that hope collapsed. The teeth were not part of the creature's jaw. They were located in its gut. Typhlosus had not possessed them. It had consumed them. The entire theory evaporated, returning the investigation to zero. All that had been gained was a single stark fact. This enigmatic swimmer was a predator, hunting in the sheltered tropical bays of the Carboniferous period. And there, the trail went cold. For 3 long decades, the alien goldfish drifted in paleontological limbo, a question mark locked in stone. Then, in the year 2022, a breakthrough. Researchers, armed with new analytical techniques, proposed a daring new identity. Typhlosus, they suggested cautiously, might not be a vertebrate at all. It might in fact be a mollusk. The evidence centered on a radical reinterpretation of its feeding apparatus. They theorized it possessed a kind of toothed tongue, a radula, which it could extend from its underbelly to attack and rasp at its prey. This is a hallmark of modern mollusks, from snails to squid. The idea was bizarre, yet biologically plausible. It seemed a perfect, elegant solution. But nature's imagination is vaster than our own. The radula, it turns out, is not an exclusive patent of the mollusks. Similar structures have evolved independently in other animal lineages, a classic case of convergent evolution. The answer, once seemingly within grasp, dissolved back into ambiguity. What was this gelatinous hunter of the ancient seas? We cannot yet say. It remains one of the most intractable cases in the history of paleontology, but it is a solitary riddle. Sometimes the Earth gives up its secrets in pairs, in the very same place. In the famed Mason Creek Formation, the same fossil bed that yielded the Tully monster, 2 other discoveries were made. They were so confounding, so difficult to describe, that their names almost seem to be placeholders. Letters from a forgotten alphabet, Eta Cistis and Escamasia. Though unrelated to each other, they represent another chapter in the story of life's boundless and often baffling creativity. The fossil record is not a complete storybook. It is a shattered mirror, reflecting fragmented images of a low hispers from a time that played by different rules. A chilling reminder that for every answer we unearth, the deep past poses a dozen more questions, each more profound than the last. Deep within the silence of the Cambrian explosion, when life was a feverish and chaotic experiment, the ancient seabeds were littered with biological questions. Among the most perplexing are 2 creatures, so strange in their construction they are known collectively as the alphabet animals. One of these beings, a creature known to science as Herpetogaster, presents a form that defies biological intuition. It was, quit central body, a perplexing growth protruded, a hub from which its 4 limbs extended. We have almost no understanding of why evolution would sculpt such a creature, or for what purpose these rigid extensions were used. The prevailing hypothesis paints a portrait of a patient filter feeder, sifting microscopic organisms and drifting particles from the water column. Fossil beds reveal a vast diversity in their size, suggesting they may have been colonial, growing throughout their lives in sprawling, interconnected communities. Even their fundamental shape was not fixed. The central mass could be circular, heart-shaped, or take on other, more ambiguous forms, a variation that hints at a level of individuality lost to the ages. Though the evidence remains fragmented, researchers tentatively place Herpetogaster within the hemichordates, a group that includes the humble acorn worms. It is a fragile link to a lineage that somehow survived, while this architectural marvel vanished forever. Its alphabetical companion, a Y-shaped organism named Phlogites, appeared at first glance more conventional. Yet this superficial normality concealed a far deeper evolutionary riddle. In its overall structure, it bore a passing resemblance to a sea anemone, a simple predator of the ancient seas. But a closer examination revealed anatomical features that were nothing short of revolutionary. It possessed bilateral symmetry, a clear left and right side, a profound leap in complexity. More astonishingly, it had a complete through-and-through digestive system, culminating in an anus. This single feature shatters any simple comparison to anemones and rewrites our assumptions about the dawn of complex body plans. For now, all we can say with certainty is that this was an animal with a mouth, a long slit that ran between what appeared to be two arms. But were they truly arms? We do not know their function. They may have been used for feeding, for defense, or for something so alien we have yet to conceive of it. They may not have been arms at all. The Cambrian was a time of biological impossibilities made real, but even its spectacular strangeness was surpassed by the era that came before it. There was a time so ancient, so populated by enigmatic forms of life, that scientists have been forced to group them into a single mysterious category, the Ediacaran biota. Flourishing from roughly 635 to 538.8 million years ago, these organisms represent the first time that large macroscopic life left its mark on mass in the fossil record. They were life's first draft, and they were profoundly weird. Among these primordial phantoms, one stands out as a vision from a half-forgotten nightmare. Imagine a tree, but one whose trunk is not bark, but living calcified flesh. Imagine its crown not of leaves were first unearthed. Their hollow, stalked cups led observers to describe them as dwellings for some unknown, miniature alien. Its true nature remained a complete mystery. It had the form of a plant, but as paleontologists studied its stem, they discovered it was heavily calcified. This was no seaweed, this was an animal. And in that revelation lies its true significance. Namacalathus represents one of the earliest known attempts by life to build a skeleton, an internal or external scaffold of mineralized tissue. It was a revolutionary adaptation, a suit of armor against a world of unseen dangers. In time, even fragments of its soft body covering have been found, faint impressions of the flesh that once surrounded its stony core. It was a creature caught between worlds, part of a global ecosystem of bizarre calm. These fossils are more than stone. They are echoes of forgotten biologies, of evolutionary paths not taken. They challenge our very definition of what an animal can be, serving as a silent testament to the boundless and often abandoned possibilities of life itself. The discovery only amplified the dread. What lay preserved in the ancient stone was, by any measure, a creature of true primordial nightmare. They called it Namacalathus. It was a being festooned with grasping appendages and bristling with rows of sharpened spines, a living caltrop capable of rending any life form that drifted too close. But its most unsettling feature was a constellation of unnerving biological portals dotting its surface. These were not simple openings. They were deep, complex structures filled with preserved organic material, their true purpose lost to the abyss of time. One can only hope they were not mouths for consuming its neighbors. As if to mock our search for patterns, these apertures were not uniform. They were not merely circles. Fossils reveal them in the shape of hearts, of hexagons, of heptagons, a geometric whimsy that feels utterly alien. This creature was not bound by a single form. It could alter its size, adapting to the pressures and resources of its environment. It was found across the globe, a cosmopolitan monster, but it preferred the crushing blackness of the abyssal plains, a ghost thriving in the deepest, most unforgiving corners of the Precambrian seas. Visually, it suggests a coral, but a coral that took a dark and twisted turn on the evolutionary road. Yet detailed analysis revealed a creature far too complex, too sophisticated in its architecture to be a simple coral. And so, we are left with a chilling void. We know almost nothing except that it lived, it thrived, and it was terrifying. But it was not alone in its strangeness. The final chapter of the Proterozoic Eon was a gallery of biological absurdities. Many life forms from this period fall into the confounding category of, what is that? Consider the enigmatic Dickinsonia. At first glance, it resembles little more than a quilted bath mat, an inanimate impression on the seabed. Yet this mat was alive. It moved. It grew. And it was part of a crowd. The ancient seafloors of India, of Australia, of the frigid White Sea were littered with these living carpets. There were so many of such bewildering variety that paleontologists have grouped them into a hypothetical phylum, the Proarticulata. These organisms have gifted science a treasure trove of bizarre fossils, each one a riddle etched in stone. Despite their abundance, despite their global distribution, we cannot confidently connect them to any animal lineage alive today. The only thing we tentatively agree upon is that they were, in fact, animals. The mysteries extend beyond classification, deep into their very biology and way of life. There is not a single, universally accepted hypothesis for how they ate, how they reproduced, or how they perceived their world. And for those who find comfort in the order of nature, there is a final, almost personal insult. Despite their appearance of perfect bilateral symmetry, these creatures were all subtly, maddeningly flawed. Look closely at the segments, the lines that define their bodies. They do not mirror each other. They are offset, a design principle known as glide reflection. It is an unforgivable, almost deliberate imperfection. Perhaps most profoundly, it is believed the Proarticulata left no descendants. They were an entire architecture of life, a grand biological experiment that after millions of years of success simply ended. An evolutionary dead end, a lost kingdom. One might think that the strangeness has reached its peak, but there is another epoch, a period so ancient and so profoundly alien that it makes all others seem familiar. To reach it, we must journey back, deep into a time that defies comprehension. We must travel 2.1 billion years into the past. This was the Rhyatian period. The name itself, derived from the ancient Greek for stream of lava, speaks of a world in violent flux. This was a planet of chaos, a crucible of fire and water, where the rules of life were not yet written. And it was here, in a region that would one day become the nation of Gabon in Africa, that something truly extraordinary occurred. In a vast deposit of black shale, scientists unearthed the faint signatures of what they now call the Francevelian biota. We search for our own origins, for the first faint whispers of our own story in the deep past. But the rock beneath our feet holds the ghosts of other beginnings and other ends. Entire architectures of life, tried and discarded, their silent testimony a humbling reminder that the story of what is rests upon an infinity of what was and what might have been. In the silent archives of the earth, etched into 2-billion-year-old rock, lie a collection of ghostly imprints, a gallery of bizarre and confounding structures. Many of them appear as simple discs, some perfectly circular, others elegantly elongated. But among them are rarer, more perplexing forms, delicaque, the frozen petals of a stone flower. Their form and features are so profoundly enigmatic that to this day no one can say with certainty whether they should be considered fossils at all. When they were first unearthed, scientists cautiously described them as colonial. Multi-cell was a staggering proposition, but not all were convinced. A chorus of dissent argued that these were not the remains of living things. They were phantoms of geology, intricate patterns formed by non-biological processes, perhaps the crystalline growth of pyrite, or mere artifacts of diagenesis, the slow, crushing transformation of sediment into stone. The heart of the problem, the reason for such fierce debate, was a chasm in time. These strange markings were dated to be 400 million years older than the most ancient multicellular life previously known. The claim was not just bold, it was revolutionary. And to study something that has slumbered for 2 billion years is an almost impossible task, especially when the fundamental question is whether it was ever alive to begin with. Since those first discoveries, the arguments have never ceased. Yet in recent years, the balance has begun to tip. A majority of studies now lean toward a biological origin. Isotopic analysis has revealed that the structures are enriched with zinc, a potential chemical signature of eukaryotic metabolism. And just last year, a new investigation concluded that the ancient environment where they were found, a shallow, hot delta, was perfectly suited to harbor life. Imagine a discovery so deeply perplexing that only now, decades after it was found, are we beginning to decide if we can even call it life. The irony is that if the Francevilian biota, as it is known, does indeed prove to be biological, we already have a hypothesis for its E-hallow waters. They would have inhabited a world almost alien to our own, a planet where dry land was a rarity, a globe dominated by a vast primordial ocean. But while the Francevilian mystery forces us to question the very definition of life, another puzzle arose not from a form too alien to comprehend, but from one that seemed deceptively familiar. Allow us to present Nectocaris. The year is 1910, the place, the legendary Burgess Shale of Canada, a fossil bed so rich it was yielding an avalanche of Cambrian wonders. So much was being unearthed that this particular specimen was, for a time, simply misplaced, lost in a deluge of discovery. When it finally resurfaced, an English paleontologist described it as a completely new and mysterious creature. It bore a passing resemblance to an elongated shrimp, a fact immortalized in its name, Nectocaris, the swimming shrimp. But the paleontologist was stumped. While Nectocaris had the general appearance of an arthropod, its fins were arranged in a way that defied all known anatomy for the group. These contradictions were so profound, he could not confidently assign it to any known phylum. He left the find unclassified, a biological question mark. It was a puzzle that would later intrigue an Italian paleontologist who became captivated by this CE. From the quietest whispers of what might be life to the clear shape of a creature that refuses categorization, the fossil record does not simply provide answers. It presents us with ever deeper questions, forcing us to confront the boundless and often bizarre ingenuity of evolution. Each stone turned over is a reminder that the story of life is far stranger than we have yet learned to imagine. From a handful of aged photographs, a scientist believed he had solved the enigma. He saw a chordate, a distant relative in our own deep ancestry, focusing on a tail, fins, and the ghost of a notochord, the defining feature of the phylum. For 2 decades, this idea took root, a settled fact in the story of life. Then, in the year 2010, the stone gave up a deeper secret. 91 new specimens, preserved with astonishing clarity, were unearthed. The revelation was absolute. This was no primitive chordate, no mutant shrimp. Before them lay a creature from a nightmare. Eiger still, it possessed no discernible mouth. In its place was a large funnel, theorized to be an eversible proboscis, a feeding tube it could turn inside out. The resemblance to a modern squid was uncanny, and a new hypothesis electrified the scientific community. Nectocaris was the oldest cephalopod ever found, pushing back the group's origins by a staggering 30 million years. But this solution created an impossible paradox. Its advanced form was an evolutish timeline. The cephalopod hypothesis was, for many, discarded. Science returned to where it began, with an enigma. A faint echo arrived in 2019, when a similar fossil, Nectocotis, was identified as a close relative. Together they form a lonely, homeless family, adrift in the tree of life. The fossil record is not a clear narrative, but a collection of whispers from an immense abyss, where each answer only serves to deepen the mystery.